see how that works.
That is interesting because, well, we've recently been asked to teach all factoring, factor by grouping. And I knew this boxing lends itself easier to this. I'll have to think how factor by grouping works out, but I'm sure there's a way because all math is interrelated. I just don't always know how. That's my big piece.
Yeah, you know, and it is a discovery process. Nobody knows everything all at once.
Right.
You guys have a comment?
I think there's a mistake up there.
Oh,
We were doing two different problems.
I think so too. Yeah, the 3 and the 6.
Change the 6s to 3s.
Okay.
And then if it's gonna be on video, it's a mistake up there.
Oh.
Yep,
Okay,
it's
so-
true.
Yeah.
It's true.
Sorry.
Oh, it's all
Very
right.
cool.
It happens.
We all have our
I
turn,
can't
right?
believe how simple this is. I was so worried about this.
What are we doing?
And there's no-
All right, so what should it be? We're looking at,
2x plus
Plus
1.
okay, oh, this
Oh,
one.
you have
yeah.
two.
Well, you have it, right?
Well, what,
Oh,
we have
I
a
took it
different,
apart.
well, I think what it is
It's a
this
different
problem is
problem.
different.
Oh, it is a different problem,
That's
okay.
the problem that's different. I don't know, it's
Plus
blurred.
Right, right,
three.
right.
Yeah, it's
This
plus
is- So
3 at the
Change
end.
that
It's-
6
just
to
change it to a
3.
three.
Yes,
Yeah.
yes, good.
There we go.
Good, good, good. So we got
Thank
another-
you.
Okay, is that all right?
Yes.
Makes
Okay.
sense.
Okay.
And this could be
Oh,
in
and
our
then this one
toolbox,
down
you know.
here.
Yeah.
Kids could pick it.
Yes.
Now, one of our teachers really hates the box method. You know why Lynn hates it?
What do you
She
mean the
gets really-
box method?
This for
This over
factoring?
here.
Oh, okay, yeah.
She gets so annoyed by that, and she hates, and the other method that we've used is the.
Did you do the
product-
factor by
Product
grouping?
sum method.
Yeah.
She gets so annoyed by that. She really, and I
So
can't
is
do
it-
you remember why she hates it so much?
Is she just a proponent to
I
just
think
Guess
guess
and
and
check.
check?
I
Yeah.
think that's kind of what it is, and she's like, well, they always mess up the system, they
We
don't
do
know
the
what
same
it
thing
is,
over
but
here,
if
guessing
you,
and checking.
yeah.
Yeah.
It's just a
That's
different.
the way of
Yeah,
looking
but
at
you
it.
know, what I tell people is, it's like, we have our favorite way. If the way we
Right,
were taught
right.
first works, then we're good with it. Otherwise, we go to a second method. So it's like if I don't know how you tie your shoes, but if I made you tie them with the 2 bows.
The little bunny ears?
The bunny
Yes.
ears, yeah. If I, you know, and if you made me do that, I'm like, I don't know
I
what
don't
to
think
do
so,
that.
yeah.
You know, I mean, it just doesn't make sense, and there is research on the fact that it went the first way you learned it, if it's stuck, then you're good with that. And you just aren't comfortable learning another way, because that's how it worked. So, I think the modality's a little bit different, because we're looking at different ways of doing it, it's not the same thing of.
Or that one way supporting another way, so that
Right.
it's not just you got lucky this time, it's that you can actually prove it another.
Another way.
She's somebody I
Yeah.
really respect. I
Yeah.
really respect
That
this lady,
is,
and
you know.
she was really adamant about it, and I just can't remember if she had some mathematical reason for it.
Other than.
And she's somebody I
I
respect
think,
who
I
has
think
a
it's
lot
just
of-
because, like, the level of math that she teaches, like, I think the assumption is that they should know the process and how
Yeah.
that's arrived.
And not have to have a.
And she doesn't wanna, like, maybe
Spend
go
the time.
back
And-
and review it.
Mhm.
As soon, I mean, 30 seconds, like, okay, remember you used to do this, or you used to do this, and just show it real quick, like, oh, okay, I got it.
It clicks.
But, I don't know, I think that's more of what it is.
She just
that
want,
it's-
does she just want, instead of all that work, she just wants, oh, I can factor that to 2x plus 1.
Yeah.
I think she wants, it's automatic,
automatic.
they should be able to do
Wow.
it.
I can't even do that.
Yeah. I had
A lot of
student-
times I can't either.
Yeah, I had a student teacher this past winter who spent a week doing all different ways of factoring quadratics, and her department chair thought that was the greatest thing. She had the Chinese method, she had some other method, which I went, no, that's Sister Helen Bernard's method, that's how I learned it. You know, but that's it, they're all different ways of doing it, and some.
Well, that's important because some, like you said, the multiple ways that students
Mhm.
learn,
Mhm.
they have to have something different. And I just, what was their product someone? I just
Yeah.
named it the fail-proof way, and they remember the fail-proof way. I'm like, just do that. If
Uh-huh.
nothing else and you get stuck, remember fail-proof way.
They do have
and
to,
you're good.
yeah.
And then they
Comes
can
up
start
a lot.
doing more shortcuts and seeing patterns, but you gotta show them.
Yeah, we do. Come on, there we go. Okay, so to sum it all up, how does it go? Come on. With algebra tiles, we can add, subtract, multiply, and factor polynomials. We can have students visualize, and that's really the big thing. We're trying to get them to understand the concrete, so then they can move more into an abstraction. So we're trying to get them involved in the learning process too. You know, they're supposed to be participants in this, and, you know, other otherwise we're up here, we're doing it so many different ways. This gives them something they need to be doing with their hands, and we can see whether they're doing it or not. Okay, so hopefully then they'll make that connection to the area model that we had taught them earlier, and so hopefully it's just another connection. So that's it.
Thank you,
Thank you
Mary.
so much.
Very good.
Questions on that? I think we're.
I think I got all mine answered.
Well, and I think we sort of
Thank
talked
you.
through it as we did
Yeah,
it.
we did. We
Lovely,
talked through it, so
lovely.
it's good.
I feel much
Yeah,
better about
good.
it.
Okay. Do you want the modeling one? Not the modeling.
The definitions?
Definition.
Yeah. If you don't, activity that we're going to do that came out of my visiting teachers last fall from this project. And it has to do with how we develop understanding for definitions, a technique for understanding definitions. So often, it turns out, a teacher says, well, keep a spot in your notebook, here's this term, write down the definition, you have this as a resource, and so on. And so this is a kind of an old method for developing understanding of definitions that I think you'll enjoy. In fact, you're gonna need these, quite a few of these actually, so I'm gonna
Cool.
just distribute them liberally while Mary's setting me up there. By recent, I mean last fall. Teachers in this project, I went to visit them in their school, and these are some things I saw. It was, it was early in September, and so in fairness, everybody's trying to get up and running, but complete the following statement and record in your notebook. Parallel lines are, fill in the blank with the definition. I saw that, yes. And another one was, parts of an algebraic expression that are separated by positive or negative signs are called, what's the word we use for that? And granted, I thought, these are terms that have to be known by students, but I'll tell you, I thought myself it was a little dry when I observed it. And how can we make that more interesting? So what I want to introduce to you is the idea of concept development for terminology. A concept development approach shows examples and non-examples, you've seen this, haven't you, from which the students deduce the essential features of the term. And then the name is given to the term after the essential features are identified. Only after. Really, this is kind of consistent with what Jenny was saying this morning. We develop the concept first and then hook it up to the term, which would be an example of procedural.
That's exactly how I did my translation activity into
Wonderful.
what is translation. We had the students, I put the class, we were usually in groups, but I put it in rows and everything. I didn't tell them that it was the coordinate plane or anything.
Yeah.
And they came in and it was post what you know, so they came in and they got to sit anywhere. And I didn't talk to them, they had to read the board and they read the directions, they filled out the post-it note, they put it on the board, and my co-teacher and I shared out, and it was what were their observations of where they were in the room. And the kids were talking about their placement, but then they started to talk about themselves, and then we handed them cards, and they had cards in there that said you have to go 2 desks up and 3 over, whatever. So then we moved, and then we talked about, well, what just happened, and then all of a sudden it's like, wait a minute, so what you're saying, I had one of the kids said, oh, this reminds me of chess, a chess movement.
Yes,
and he
yes, sort
identified the
of,
chess
what's
and-
that game?
Battleship, yeah, and then they were like, oh, this is a coordinate plane, oh, we didn't move, nothing changed about us. And I was like, great, do you know what we call it? It's in the learning target, and then they identified it, and it was like 10 minutes, done.
And not only is it done quickly, they know.
They remember it.
They know what the words mean, they remember it,
Mhm.
yes. So, the example I have for you, really quick, is a little bit lame, but to describe how it works, I'll make my cards that show examples and non-examples, and I will show you an example, and I'll put it under this category. Here's an example of the concept, and I'll show you my non-example, and I'll put it in a category that's a non-example. And I want you to report the information you have about this mystery concept or mystery term each time a new card is added, and raise your hands to answer. And as this process continues, you may form a hypothesis about what it is we're looking for. And when you've formed a hypothesis, tell us about it. Tell us what you hypothesize the mystery thing is. So, now I really apologize for this example. Oh, and again, It's very hard to see. I would make up a card with what I have as A here being 73 degrees, and over here, another angle being 17 degrees. Anybody care to hypothesize
Wait, say it
what I'm
again.
going for?
Say it
Those are
again.
angles drawn.
Yeah,
These are examples.
Yeah.
Yeah, these are examples. Can I do this?
Well, let's find out.
Yeah, you can.
What do I, oops,
Just don't put your hand on it.
Just don't touch it.
There you go.
There we go. Here's an example. So I have those two on a card, and here's an example. And I have these on another card. I told you I didn't work
So
very hard.
A is not equal?
So
No,
count.
They're both
Those
examples.
are examples.
A is one
Oh,
example.
you have to put the pen down.
Thank you. So then our non-examples would be an angle that's 14 and an angle that's 45. Well, here's a non-example, 3 angles, one 25, a second 25, the third one being 40 degrees.
Really? D is a non-example?
D is a non-example, yes.
Can you go back to A, please?
Sure.
Angles should equal nine.
Well, but D equals 90.
Amanda?
Warm-ups.
Yep.
What?
I just told him this is his warm-up for his geometry class.
Oh.
I'm teaching geometry mostly.
Are you, okay, yeah.
Yeah.
And you wanna go back to A?
Yes,
Well,
please.
Or do you want me to say what?
Yeah,
this
no,
letter is, or
I'm
no?
pushing us quickly
Okay.
because I think it's
Yeah.
pretty obvious to us. I hope it's obvious what it is, and of course it's gonna take our kids, is it obvious? Maybe it's not.
Well, those sum to 90, but you
Okay.
said D was a non-example and its sum was 90.
That's
But
true.
it's two angles that sum to 90. So
It's-
are you going to say maybe that they are complementary angles?
Should I? I've categorized it
Well-
as a non-example.
That would mean that one 40 degrees, because it has 3 angles in it, and complementary are 2 angles that sum
So
to 90
you
degrees.
you deduced something from the non-example about the characteristics of what we're looking for. And we want our students to make that distinction. I at the university have had kids in math class who think they can have 3 angles adding to 90 and call them complementary. One such person was even going to be a math teacher.
Well, the 40 does have an angle with it. I couldn't see
I know,
that,
there-
and so that's what made me think that was something else.
Okay, so without much ado, this is about all that I have. I think I may be sure there's more after this. Oh, I want you to try this. I gave you cards. I want you to pick a term that you would be teaching at some point, and maybe one that you've noticed students have difficulty with, remembering all the features about. And would you try to devise some examples and non-examples of that? And let's try this game, so to speak. Let's try it out on each other. We'll see if we can, if you show us the examples and the non-examples, we'll see if we can come up with what concept is attempting to be developed. I'll give you a little time, because you'll want to think about your term. You want to think about what term, and you want to think about the examples that convey or illustrate what you want students to get about.
The example that I have videotaped is the one that I was talking about.
Uh-huh.
Do you want to show that, or?
That'd be wonderful. That'd be wonderful.
I can pull it up.
Terrific, yes.
Potentially.
Thank you. I used blue, a little blue marker. What am I saying? We as less than a year ago.
These are tenured? Hopefully not.
Just someone who needs to learn some new
Yeah,
strategies.
Yeah, yes. You can make as many examples as you want, And what I've noticed is that students, because these are gonna be a little hard to see, aren't they?
We can show them to our table. We can exchange with the person next to us.
But we wanna, we all wanna share.
Well, I wanna see Patricia, so come on.
Yes,
Patricia
Can
Mary.
we pass them down and like do it
I
like
can,
that?
I can draw it
Yeah,
up
but
there.
let's
I
do
can-
it like a
Board work,
classroom.
You can just go up and put yours up now that you've done the thinking.
And actually, what I had on this thing is a little misleading, because I expected your card to have one example and one non-example, and that's why I gave you multiple cards, so I was a little misleading, but this will work, this definitely will work.
I did not.
Oh, yes, I think I'm gonna like this.
I'm excited. I wanna see if you guys can get it.
So maybe you could just pass along and show to everybody, could we do
Yeah.
that?
Sure.
So that,
I'll start. It's like Vanna White.
yeah.
Hold on.
Oh, I see
You can
that-
check your answer on the back if you want.
No, I don't wanna know.
I like to make self-checking things.
Of course.
I told the students, like, if they need just an answer, we should be able to check it.
Flip it on the
and
back.
it's the concepts that
Let's see.
they should come to me for. This would be for my sixth graders. They struggle between these before we do fractions.
Yeah, back to my old job.
Yeah, you took care of me last year, didn't
Can
you?
we,
Can we zoom that in a little bit? Out?
there, that's good.
So A and B are examples of our concept.
I thought we were just supposed to have 4, so I probably would.
With kids, you probably need more. Yeah. And non-examples.
Well, the non-examples look like multiples to me.
Yeah.
Like you
Yes.
add the same amount to get to the next one.
Except letter D.
Yeah,
One.
D's not a multiple, it'd be like
That's a
a
sum,
recursive
yeah.
routine for one, getting one.
Well, they're adding 3 each time.
Right,
Okay,
that's so
Mhm.
adding
Mhm.
3,
Mhm.
adding 1, but
But
letter
those are the
B
non-examples.
But letter B throws me for that because I
Yeah.
need one more.
Another way I may have written A if I wanted to, I might have.
That's not smart word.
Let's get it one.
Oh.
I may have chosen to write it like this.
Oh, I like this. I like this. I'm clearer now.
That would have been how I would have differentiated.
I'm clear.
Oh, okay.
112,
Yeah.
260.
So factors?
Factor
One.
pairs.
And I wanted them to see a prime number example because that seems to throw them that a prime only has 2 factors.
Okay, this could
Okay.
easily be used to demonstrate that with prime numbers, you're only gonna come up with one set of two factors.
And my students get mixed up between counting multiples and factors. That's a
Yes,
struggle.
yes,
Okay.
yes.
So,
And that's
although-
what you were showing us.
Yeah, although what I may have done with this is I may have given them way more cards from this and asked them to sort them
Yeah, yeah.
into what categories.
Made it
they
into a
want.
card sort activity,
So
great.
you're saying they're struggling with the difference between like least common multiples and
Greatest common factor.
Is that kind of where the problem is for them?
Yeah, right
Okay.
before.
Do you
And
know-
then
Oh, I'm sorry.
they haven't mastered fractions, and then
Yeah.
7th graders are supposed to be able to do all operations with fractions, and it's just a gigantic struggle. And in the 6th grade, we multiply, but they don't understand finding factors of a number to help them simplify. Like simplifying before you multiply is just.
I have calc students who can't do
Sure.
this. So
Conceptually.
don't feel bad.
And
Yeah.
so like when,
Don't feel
well, but I
lonely.
tell them
Yeah.
and I give them examples of like, I do pictures, like we have 3 smiley faces up here and 4 smiley, like to try and get at that, and I show them examples with exponents because that's or variables they'll see eventually. And they just, I don't know.
I think that stuff's harder for kids than some of the higher level mathematics.
I agree.
Well, I
I
think the
agree.
higher level math, you see where it's going to, and I don't think there's as many applications for it. Like, in real life, where do you multiply fractions? There's just
I
not
do.
a.
Oh, don't talk to a
You should have
carpenter.
been here last year. We did a whole thing.
We
on
did
this.
a lot of that. you know.
Well, there are some places, but in
It's
terms
harder to
of